For this part, I can still speak alone and explain you things about each slide. Or you can also maybe raise your hand and say, I disagree with you, or I agree because of that, or I've seen that. Share your experience. Could be good to have some interactive discussion on this part. So the first thing I want to speak about is when we are speaking with any asset, we are speaking of the life of this asset. How long does the asset can live before we need to renew it? And there are very different life definition. And the two main different life definitions that you will have is the service life. How long does your asset can fulfill the service is expected to do? You have your pen. How long can you write with your pen? And then you have the technical life. How long does the asset will be in good condition? And that's very different. And that's also why it's sometimes very difficult when you inspect a system to know if you need to do something. Because it's not the most complicated part to have the condition. You have your pen and it starts to be broken, this part, this. You can see it and you can guess that it's not in good condition. But maybe you can still use it to write. Or maybe your pen is in perfect condition, ink inside, everything, but it's not working anymore. So that's not only by visual inspection that you will see that the pen is not working anymore. So we are often focusing on trying to have the technical life, but what we really want and what is difficult to have is the service life. To know when the system is costing too much to maintain the service, or when the system is not maintaining the service. So that's something very important. And you also have the design life. Any system has been designed for a specific life. Don't ask me the question on WSUD, because I think nobody knows how long the WSUD is meant to work. But any system is supposed to have a service life, a design life. And any system is supposed to be replaced after this time, system or asset. And usually this is known by experience on the service life of the system that has been installed first. But WSUD is such asset that we are always building differently the system. So you cannot only base your experience on the previous WSUD. You need to have other way of knowing when you should replace it. And there is also this easy way of defining the design life, which is economical. You will base your design life on just economical definition. For example, if you buy a computer, when you buy a computer in a company or any place, you will say a computer is supposed to last for 3 or 5 years. It's not in bad condition after 3 or 5 years. It's just that the service is not given because we need increase of calculation, memory, and so on. So we say on economical basis, this computer is meant to last for 3 years. So we need to put aside money to be able to renew the computer in 3 years. So we are doing kind of the same with the WSUD, but in the opposite direction. We look on how many WSUD we have, and then we look on the money we have. And then we say, okay, based on the money we have, we can change the WSUD maybe every 40, 50 years. Doesn't mean that this WSUD will last 40 or 50 years, maybe shorter or longer. It's just economical. You look at all the money you have, and you, based on that, you say, okay, I have only this money, so I can only do this renewal. So that's very different thinking. Another point which is very difficult with WSUD, you have this picture. First, you need to see there is a swale, but you don't see the swale. So the first thing is it's difficult to know the condition and maintain it if you don't see it. But it's the case on many WSUDs. So you have a swale along the road. You all know what a swale is? Yes? Okay. So you have this swale, and you need to maintain it. Mostly it will be cutting the grass, and you will monitor it. Who is in charge of the swale? Who should do that? That's the complication. You have the green space department because it's a green space. So they can be in charge of your swale. But it's also along the road, so it's often part of the road. So the road department is in charge of the swale. But there will be litter in it and you need to clean it. So maybe it's the cleaning department that is in charge of the swale. They will go to clean the swale, so maybe they can cut the grass in the same time. And then you have the sanitation department or the water department because it's a water infrastructure, so it should be managed by the water. So this is a very difficult problem. For each asset, if you don't know who is in charge, then it won't work. So you have to give task and say this need to be done by this, and then you have to share the knowledge. We went there, we clean it, we've done that, you don't have to do it. Or when we went there, we've seen that there was a problem, it seems that this part is clogged, so maybe you have to go and work and do that. Yeah, you have a question?
I do. I'm thinking in that one it could be even worse because there's another asset in the swale, which is that light post and electricity post. And the owner of that asset might come and make modifications to it that affect the function of the swale.
Yeah.
Without any reference to those who manage the swale.
Yeah.
And all of a sudden you find your swale doesn't work.
And that's a very good point. You have indeed electrical pole in the swale. Why? Because when they decide to install electric pole, nobody told them that it was a swale. So even at the start. So, and when you will do the swale, maybe you will impact on the pole, and when you change the pole or you change electrical wiring, you will impact on the swale. So this is even more complicated than the picture. So it's all about task attribution, but behind the task, the most important is the money. I have this money for my department. For my cleaning department, if I use the money on this swale, I cannot use it on this area. So what I want is you to take charge of the swale. And it will be the same on any department. If this management of this shared infrastructure can be done by another department, everybody will try to give it to the other department to reduce their internal cost. So that could be very difficult to discuss about that. And there is no rule that will work everywhere. But the most important thing is to define the rule. In some city in France, they decide that if an asset has only grass, it will be maintained by the water department. If there is any vegetation more than grass, it will be maintained by the green space department. And this could be a solution. There are many solutions, but the most important is to discuss about that. I think you have a project to do. So when you start to choose the asset you want to install on the project, you will start to think of who will be in charge of that. And maybe when you will write your project, you can have a part on what should be done on this asset and who should do that. Because if you do that from the design, it will be much easier for everybody. If we wait for the system to be built, then the discussions are very difficult. If it's made from the design, everybody will be part of this decision and will accept it or discuss it. And you don't wait to have the asset built to say, not possible to maintain it. So maybe you can think of adding a chapter on that.
Can I just pick up on that? That's a really important point. My own experience has been that best designs occur when people who are going to be responsible for the maintenance are involved in the design, because they see problems that idiot designers like myself just would never see, because I don't have experience maintaining, well, some, but broadly don't have experience maintaining these things.
In the same way, when you will choose a system, when you design a system, you want to say your system is the best, so you will say, my system is the less expensive. If you build this, that's less expensive. But if we have to renew it every 5 years, that's not the less expensive system. So if you don't take into account the life of the system, then it's very difficult for you to say that your system will be the best one on the long term. Another point very important when we start to look at WSUD is that they are existing since 20, 30 years, but they are not really, they are starting now to be monitored more and more. But it's new job because it's new skill. And they are the people that are often are in charge of monitoring, inspecting this WSUD are people from water department and mostly people from sewage or sanitation. And if you look at what you're doing when you're inspecting a pipe network, a combined network, or a sewage network, and when you look at a WSUD, or even a drainage network, we can say on top that you have drainage network also. It's very different. If you have a drainage network, you have pipe, you don't want sedimentation in the pipe. You want the flow to go. You don't want to have to clean the sand or whatever. So you need the pipe to be always clean and the flow to go. But if you have a wetland, an infiltration basin, you want the sedimentation at the start of the system. So you will build a sedimentation basin. So that's very different. So if you send someone used to pipe to go and check this, you will say, there is a big problem, lots of sedimentation in front of the system. We need to do something. So no, we don't need to do something. It's made for that. We want all the sediment to go in front of the system. Then we can collect them, and they won't be spread in the whole system, and they won't clog the system, and so on. So it's really new job and new skill. If you have combined network, you have flow even during dry weather. If you have a stormwater system, you don't have flow during dry weather. So if you have flow during a dry weather, that's a problem. So you have also to take into account. So expectation and knowledge is very different. So for me, it's really a new job to work on auditing, inspecting this system. This one, I like it a lot, not because of the picture. It's more because of what's on the top. That's, for me, very important. It's all about your choice. When we are speaking about maintenance, you have two kinds of maintenance. One is the corrective maintenance. I wait for the system to break, and then I repair it. I have my car, and I will drive, never check it, and one day it will break, and then I will bring it to the garage and repair it. That's corrective. And then you have the preventive maintenance. I don't wait for any failure to arrive. I will check it. I will go to the garage every year, check oil, or do whatever I need to do, because I don't want the failure to happen. So that's two very different approaches of maintaining your asset. If you are on the corrective maintenance and you wait for the failure, that's what we call the run to failure, you will spend much less on monitoring because you don't do monitoring. You wait for the problem. But you will have very important costs because you have consequence of failure, the impact. So this impact are often costing money. And you have increased rehabilitation costs because you have often the need to make urgent reparation. You need your car, you use it every day, you don't check it, it breaks. You go to the garage and you will ask, can you repair it now? No, I need it now. And it will cost you more because you have to do it now. You were supposed to do something else, but you have to go to the garage and you're asking for urgent rehabilitation. So it will cost you more. So on the short term, this run to failure seems good because you don't spend on monitoring. On the long term, it's not a good way of doing that. And we are doing it on many infrastructure, and we are doing it often not by choice, but because we don't have enough money, resources, or information to do something else. So if we can shift to the proactive maintenance or preventive maintenance to act before the failure, it will be better because we will decrease this impact and rehabilitation cost. And this impact and rehabilitation costs, they are much bigger than the monitoring cost. So how can we do preventive maintenance? You have different options. The first one is to do scheduled inspection. You go and you check each asset every 6 months, or maybe you don't have enough money. So you go and check every asset every year. And you hope that you will come before the failure, because you're coming only every year. I call this the blind inspection, because when you go there, you don't know what you will find. Maybe you will inspect a system that is working perfectly, and you're losing your money, because you could have inspected something that is failing. Or maybe you will come just after the failure. So that's what we can do. It's not the best. The best will be to anticipate any failure. So you have your model for each asset, and then the computer blink and say, oh, you have to go, this will clog. And you go on site, yes, it was almost clogging, so I will repair it before. But this can be done only if you have very good models, so if you have lots of data. And in the WSUD world, it's not possible. And it won't be possible, I think, for at least a few years. So as long as we cannot do the condition, the prediction of the condition, we cannot anticipate the failure. So what's left? It will be to monitor always every asset. And the monitoring cost will, of course, increase a lot. But if you are monitoring every asset always, you should be able to avoid any failure. So you will also decrease the impact and rehabilitation cost. So on the paper, that's the best solution on the right. And then we come back to one of my first slides. There is the CAPEX and the OPEX. Monitoring is OPEX, and rehabilitation is CAPEX. And you cannot transfer money from CAPEX to OPEX. So even if you are saving a lot of money on rehabilitation, you're saving money on CAPEX. You still do not have more money on OPEX, on inspection. So that's the limit of the system. But mainly that's the idea, to go on continuous monitoring. So I think this is one of the slides that you should keep in mind. Yes?
What's the difference between scheduled and continuous?
Schedule is that you will go every 6 months, you go and you will do some tests, some inspection, and you go every 6 months. Continuous, you leave a monitoring system. And this system will check the water level every 5 minutes, every 10 minutes. So it will check the water quality. Or you are doing it always.
So it's like a computer system or something instead of schedule where it's a person going?
The schedule is often a person that will go and check all the assets. You cannot leave a person in front of each asset, so it's kind of computer. You will use a small system that will monitor something, water level or soil moisture, and that will send the information. And so you will be in your office, in front of your computer, and you will receive the data. And maybe if the data start to be not good, you will receive an alert. The computer will say, problem. Yeah, you don't. The best will be maybe to leave someone everywhere, but you don't have. It's not possible. And that's also a very good question, because continuous monitoring means that you need to install system that will give you information of the condition. And you can choose to leave a camera. You will put a webcam on top of every system. And then you are in the morning in front of your screen and you check all system, all assets. You look for the camera and you check that. That's only visual. You don't know what's happening, but it can be a solution. Or you can decide to have the water level or the soil moisture. But you may have less information per asset. You will have them always, but you may not have as much information as you want. So you have to choose wisely what information you want to monitor.
Can I just give one current example? So Melbourne Water has invested some few $100 million in stormwater wetlands, and they are finding big problems with the outlets of these wetlands getting clogged, which means the water level stays elevated for long periods and they lose a lot of the vegetation in them. And they've often spent $1 million planting these wetlands. So they're starting to implement a real-time monitoring, so not yet controlled, but real-time monitoring system that's measuring water level at all times and looking at rainfall. And if the water level after rainfall event doesn't drop the way they predict, it will send an alert to the local asset manager to tell them to go and look at the wetland or the contractor who does the maintenance and to go and unlock that outlet. The next step is to turn that into real-time control where the system will then operate, for example, like gates that would clean the outlet itself from cutting any debris that's there. So, we're working with them to try to take the next step.
Yeah, you have really the first step that is not it start to be implemented will be to have the information of the condition in real time, and then Tim is speaking of acting automatically. So if something is happening, then the system will respond, open a valve or yeah.
In the long term, it probably costs more in labour to send people. And
Yeah.
Usually what we've seen is the people who go there won't necessarily understand how it should work anyway, so they might not plan it when it should be cleaned and the cost of rehabilitating one of these wetlands can be millions of dollars. So investing $60,000 in one of these control systems, very good value relative to the cost of asset renewal.
The most important cost is renewal, rehabilitation. It's capex, so it's the most important. And then if you go on monitoring, the most important will be human resources. And then there will be the system. But the human resources is what costs most. But yeah, behind that, you have to keep in mind this problem that what is capex is not opex. So if I can save money on rehabilitation, I cannot put it on monitoring. So this is really important, but you are also to think that the two are different budgets, and that's quite a big problem. And if we go on schedule, what is done often for now is the schedule inspection. You go and inspect the system every 6 months. And if you go and inspect the system every 6 months, you have to take into account that your system will be in very different situation. You can inspect a system, you have to inspect your system during dry weather because you have vegetation, and vegetation is part of the system and has a role to play. So you have to check that when it's not raining, the plants are in good condition and you still have enough vegetation for when you will need the vegetation when it will rain. And then you have to check that your system is working with small rains. It should not overflow, so you need to go and check your system. Small rain, is it working fine? Bigger rain, is it still working fine? And bottom right, that's biggest rain. Your system is not designed for this amount of rain, so it will overflow. And you have to go back after and to see if your system is back to normal. When the overflow will disappear, you have to be sure that the system is back to normal. It hasn't been damaged. So when you do this schedule and you go every 6 months to check the system, you may miss part of this. And you often miss part of this because I think it's better to go and check the system outside when it's not raining. So you will often see the system on dry weather because you don't want to be outside during the rain. So you don't check often your system during the rain. So if you don't do the continuous monitoring, you may miss part of the life of the system. And then there are, on the bottom left, unexpected events, and anything can happen. And if you go every 6 months, you will also miss this. This one was in Lyon, in France, a few years ago. In a detention basin, a plane crashed in the detention basin. A small plane crashed in this basin. And so you may have the damage related to the plane, and then you have also all the pollution related to the fire that you need to stop and everything. So, and if you go in 6 months, you may either discover it on the newspaper, or much later there will be something strange. So anything can happen. That's maybe the strangest thing that happened, but anything can happen in an asset. So you need really to go on the continuous monitoring. Another point, very difficult when you're doing monitoring, is that we are not speaking of the same asset everywhere. You have very different assets. You have wetland on the top right. You have for a swale made of stone, or trench in the bottom right. Difficult to know what it is. You have porous road. You have a big infiltration basin, which is also a park, and part of them, sometimes you have underground pipes that will facilitate the infiltration. So every system is different. Every system works differently. And if you don't understand how the system works, you cannot know if it's working well or not. So that's very important. And you need to adapt the monitoring, the inspection, investigation, based on the system, its component, its surrounding, and what you expect also. So that's a very difficult problem. When we are dealing with pipes, a pipe is made to transport the effluent. So you will check that the effluent is transported. There is no exfiltration, infiltration, or collapse, but that's the only function. And all the pipes are almost the same. Material, size will change, but they are all the same. But this, with the WSUD, it's much more complicated because each system, and again, this needs to be defined from the design. When you choose a solution, you design it, you need to know what component will be in your solution, and you need to know what expectation you have from the solution. Is it only about runoff, infiltration? Is it also about landscape? Is it about biodiversity? Is it a parking? And based on that, you need to explain how it works, what should be inspected, and when it should be inspected, and by who, if possible. And that starts to make the exercise of designing much more complicated. We were discussing about continuous monitoring, and the main problem for now is that the OPEX, the inspection budget, is not increasing. So if you want to monitor every asset, you cannot increase the inspection budget, so you have to decrease the inspection cost. So we are working a lot on low-cost monitoring, and the idea is to be able to know how the system is performing with minimum cost and minimum human resources. So the system will be installed, work autonomously, and send the data and alert if something is happening. So we are able, for example, to build water level monitoring under $100, which is quite good. So it means that you can install quite a lot with enough accuracy, maybe not for a model, or it could be discussed, but at least to know that the system is working well. You have the inlet, you have the outlet, you have the bypass, and if the water is not flowing, then you will see that on the water level. And if you see that, you can alert. And then you can go and see what's happening. So we are able to do this kind of system that are low cost, that give information in real time. And these systems are also self-powered because we were discussing these human resources. If you have to change the battery of the system every month, the system can be low cost, but you still have a need for lots of human resources. So it's not only the box that monitor itself, it's the whole environment. And I will finish with that, maybe, yeah. I will finish with that. You have also to keep in mind when you're dealing with this WSUD infrastructure that we are always in a constant transition. System is always evolving. You have one WSUD, we are trying to put treatment system, several WSUD, one after the other one, because it seems to work well and that's a good solution. You still have the drainage network, so you need to work both on the drainage and the WSUD. In some part, you will replace the drainage by the WSUD. In some other part, they will still work together, so you have to make them work together. You have lots of public WSUD on public space, but we are also pushing a lot on private WSUD. And if the private WSUD are not working, we will have too much water to work on the public WSUD. So this to be think globally. And then there are lots of emerging challenge and long-term objective. In some country outside of Australia, they are speaking about adaptation to climate change. It seems that it doesn't exist in Australia, this climate change. We are working a lot on the efficient use of energy, and there are always new technological innovation. So if you are not looking for innovation like the low-cost sensor or any other system, or the way you build system, then it's not working. So it's very important that you always think, now and later, that the system is not fixed and you are living in a constant transition. It's very important. And another way of saying that is that you are learning this week lots of things about WSUD, but you also need to always think outside of the box. And you have to use what you've learned, but you have to think also differently of what you've learned if you want this to work. A good example is this equality, which is not an equality. You need to add one symbol to make it right. So you've learned lots. What do you want to move? You say move. Not me? Or That's it. Yeah, that's it. That's thinking outside of the box. Because you see Roman numbers, so you're thinking in the box in Roman numbers. But you have to take the problem differently. And that's a lot about that. You have learnings of how to design, how to do this, that. But there are also lots of things arriving new, and you have to think differently. You will, yeah. So keep that. It's very important. And I will finish with this glimpse of the future. This could be the city in 20 years, or this could never be the city. Who knows? But it looks like what we have today, but it seems to be very different. And in this city, the water is everywhere. Water is used for transport, for many things. It's all about recycling water and working with water. So I think the slide will be shared, so you can have a look on different parts of this and think of what you see and what is different compared to what you have today. And that could be a good way of starting to think outside of the box. And this design, this draw, come from a European project that has been finished a few years ago. And you can also have a look at the website. There are lots of training information that maybe will give you more insight. I think that was, yeah.